Hey, what's going on guys? In this video we are going to talk about diode circuits. Here we have two diode circuits and we are going to calculate this current and the voltage. Now let's look at this first one. When we deal with diode circuit, what we do is we assume this diode is on. Okay, we assume this one is on. So when the diode is on, or in other words we can say this is in forward bias. If it's in forward bias, we replace this diode with a short circuit. And the direction of the current is going from anode to cathode. Anode here is this one, cathode is this one. For this one, anode is here, cathode is here. So here you can see anode to cathode. So this direction, this is going to be the its direction. So if we redraw this circuit, assuming this diode is on, we are going to have the circuits like this. We are going to have a straight line because this is short circuited, and this is connected to the ground. And then we assume the current's direction from anode to cathode, so we are going to put an arrow in this direction. And we have to have the current positive. If the current is negative, it means the diode is off, our assumption is wrong. And let's calculate the current. This is I, and the resistance is 1K, and the voltage is 10 voltage, and this is 0 voltage. And since the current is in this direction, the voltage difference is going to be 10 minus 0 divided by the resistance in between 1K. That's going to give us 10 milliampere. Since the current is giving positive answer, our assumption is correct and the diode is on. This is in forward bias. And also we know the voltage. Since we don't have anything in between, here also, like if we assume this is the one we are trying to find, this is the voltage, right? This is the one we are trying to find. This is also going to be 0 because we don't have anything in between. So this is also 0. Let's look at this one. Here we do the same thing. We assume the diode is on at first, and if it's in forward, diode is on in forward bias. If you assume that when we short circuit this one, we are going to have something like this, and the current's direction is going to go from anode to cathode. Here for this one, anode is here, cathode is here, so we assume current is in this direction. But for this one, anode is here, cathode is in here. So we have to assume current is in this direction, and we have to get the current positive. Otherwise, it's going to be off. Our assumption is wrong. Okay. So here this is 1K, this is 10 voltage, and let's go ahead and calculate the current. For this one, since the current is in this direction, this is going to be 0 minus 10. Voltage difference is going to be 0 minus 10 divided by 1K, and that's going to give us negative 10 milliampere. So since we are getting negative, this means our assumption is wrong. Current is not flowing in this direction, right? So therefore this is off. The diode is, the actual answer is diode is off. This is in reverse bias. If it's off, this is reverse bias. Reverse bias. If it's reverse bias, this circuit is not short circuit. This is an open circuit. So there's no current. Current is 0. So when we have reverse bias, the actual current is 0. So this is wrong, right? This is wrong. And this is the voltage across here is going to be 10 voltage. That's how we got 10 minus 10 divided by 1K. That's going to give us 0 ampere. Okay. And that's how we do this kind of problems. I hope this helps. Thanks for watching.